your name. So these are the things we're going to do. So we'll do one exercise today. So before we do the exercise, we'll do an investigation because maths, much of it are all discovered. So if you can discover something, it's really fun. Part of learning maths is discovering maths, I believe. So let's look at this. All right, look at a very simple problem. It all starts with something simple. 15 divided by 3 is 5, right? We say 15 is divisible by 3. Divisible means that I could divide 15 exactly into 3 equal parts. So I've got 1, 2, 3. Actually, 1, 2, 3, 4. 1, 2, 3, 4, 5. So there are 15 dots. I could divide 15 dots into 3 equal parts with no remainders. So we say it's divisible by 3. Divisible means can be divided into by 3 with no remainders. However, 15 divided by 4, just let me finish, you get something else. So let's have 15 dots again. But let's say we try to divide into 4. So I got 4 dots, 4 again, 4 again. I divide into 4 groups, yeah. 1, 2, 3. That will be something like this, right? So I've got 15. So that's one group, second group, third group. Is that how it works? Divide into four groups. Sorry, that was wrong. Try this, sorry. 1, is it like that? Divide by 3. Actually, I got. I know. So that's what I'm trying to say. I'm trying to say 4 groups. You will get 4 groups. Each group will have 3. I made a mistake. All right, I know that, but that's not the point I'm trying to make. All right, okay, I stop and watch this. I know what I'm doing. Okay, I got these dots. So I got 4 groups. 1, 2, 3, 4, but with 3 remainders. Yeah. So we get the divided by that is 3, remainder 3, which is not really nice because that's okay. But anyway, we say 15 is not divisible by 4. Okay. So now these are easy questions because the numbers are small, right? Because I could either draw a picture or know my timetable. But things get tricky if I try to answer a question like this, which says 145, is it divisible by 2? Some of you may know the answer. How about by 5? How about by 10? And that's the purpose of this lesson, is to find out whether a number is divisible by another number without drawing pictures, without even doing long division. And that's actually very useful. And these are called divisibility tests. But before we do that, we're going to discover each rule. Rather than say, that's the rule. It's just boring, right? We're going to discover them. And it's actually quite interesting. And you're going to learn pattern. Maths is about pattern. It's not just about crunching numbers, how to multiply 1,350 by 500 and something. That's not what we do. It's all about thinking. Okay, now I have to stop for. All right, so golden rule. A number P is divisible by the number if P is a multiple of Q. Okay, so notice that 15 is a multiple of 3. That's why divisible. But 15 is not a multiple of 4 because like 4, 8, 12, 16, so it's not divisible. So we're going to use this rule as part of our investigation. Okay, that's very important. Okay, let's look at this. Let's look at the first one. Multiple of 3. 15 is a multiple, is divisible by, actually, that's what I just said. Let's write it in word. Divisible by 3 because 15 is a multiple of 3. That's how we tell if something divisible. So now we have narrowed our investigation. The number 15 is not divisible by 4 because 15 is not a multiple. So there is a one-to-one correspondence between multiple and divisible. Okay. Now, what we're going to do is we're going to move on to the next column. Divisibility test for 2. Now let's list the first 10 multiples of 2. Okay, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And we're going to see if there's any pattern in there. What do you notice? Raise a hand if you can tell me. Yes, William. Oh, yeah, but I know you go up by 2, but we want something that we can sort of look at it and work out. That was a good observation, but not enough to be a good test. Okay. Tristan, go. I know, but how do you? Well, that comes to the next question. What is even? Like, you still haven't. That's okay. Good try. Okay, you.
So, okay, so even is every second number, and they're ordered.
Yeah, I know it's every second number, but that's still not enough. Okay. Emily. Sorry, Brooklyn. Okay, let me tell you something. All right, okay. Listen, Ella. I know that's what we're trying to find out. Okay, watch this. Watch. Notice that. What's the pattern? The 2, 4, 6, 8, 0 is start to. What's the word? Justin. Repeat. Yeah. So you check the last digit. So the number is divisible by 2 if it is even, but the last digit has to be 2, 4, 6, 8, or 0. Does that make sense? That's how we tell if something is even. By looking at the last digit. How cool is that? Thank you. Next question. Well, just let me finish, and then I will ask you for pattern. The first 4 multiples are 5. Let's see. 5, 10, 15, 20. Okay. Raise your hand if you can tell me what pattern you see. Now we've got some strategy. Okay. So someone else? I'm gonna ask. You answered 3 questions already, I know, but I'm gonna pick someone else. Ria. Excellent. Ends in 50. Is that what you're gonna say, Julian? Well done. She read your mind. Well done. If the last digit, did you write it down? You should write it down.
Yes, sir.
Is 5 or 0. Well done. Okay, hang on. Stop there. Got interruption. Continuing, divisibility test for 10. List the first 4 oh, this one's like no-brainer, but anyway, let's try 10, 20, 30, 40. Okay, who want to tell me? All right, Joshua. No, seriously, can't get. All right, someone else. Joanna, how do I know it's divisible by 10? What do you look at? Huh? Ends in 0. Well done. If it ends in 0, I think that's a better way, right? The last digit ends in 0. Okay, any question? We've discovered 3 rules already. 2, 5, and 10. No. That's finished. Like what?
You asked any question?
Oh, then what is it? What's your question?
It's the last digit is 0.
Yeah, someone answered already. Go.
It's the number 2. So it goes last digit is 2, 4, 6, 8, or 0.
Yeah.
That means 0 is like, how does that, doesn't work because 0 is not.
Seems to be that, well, okay, that's a good comment. Now 0 appear all 3 tests. So that tells you if something divisible by 10, it has to be divisible by 5 or divisible by 2. If that makes sense? Yeah. So if it's divisible by 10, it must be divisible by 5. Does that make sense? But not the other way around. So it's like if I draw a Venn diagram, watch this. Divisible by 10, and the smaller group is divisible by 3, by 2, because you have to have more condition. Actually, no, hang on, it has to be the other way. Actually, wrong. Doesn't matter. Forgot what I said. Yeah. It is 0 divisible by any number. Yeah, no remainders. 0 remainders. Yep. All right, let's continue. All right, continue. Next page. Okay, exciting math is very exciting. Let's move on. All right, now 3 is a bit tricky because the pattern is not as simple. let's see if we can discover that ourselves. 3, what's the next one? 6, 9, 12, 15, 18. Well, looking at the last digit seems to be not work, right? Because there seems to be at least there's too many, or there's something, right? So at this point, the first 3, 2, 5, or 10, you look at the last digit, no problem. But last digit for 3, it doesn't work. But let's offer you a lifeline. Let's see what happens if we add the digits together. And that's when we get interesting. OMG. Oh, we discovered something. That will be add the digit. Okay, now listen carefully. The number, hey, seriously. Okay, a number is divisible by 3 if the sum of its digits must be divisible by 3 or multiple of 3. Does that make sense? So, yes. Yeah, but you're reducing it to a smaller number. If that makes sense. So that's obvious, 369. You reduce it to a 1-digit number. Does that make sense? So if you add the digits, so I will show you some example later on, but let's go through this. How about multiple for 9? Let's try that. 9, 18, 27. Continue. You will have to stop, otherwise it will stay longer. Okay, next one is 27, 36, 45, 54, right? And there seems to be some pattern there, but raise a hand if you can tell me what the pattern is. That's very exciting. 81, okay, etc. on 90. Okay, go. All right, someone who haven't tried. Okay, Noah, Carol. Yeah. I know, but what are you trying to say? Like, the next one's 99, by the way, and then 108. Okay, now what are you trying to say? What's the pattern? Yeah, but then it doesn't work for this. But that's good observation. But what's that? Again, similar to the one we did before. Someone who haven't said anything. Okay, all right. All right, go like this. All right. Okay, Harrison. Sorry. Yes, add up to multiple of 9. So sum of the its digit must be divisible by 9. So if we add the digit, watch this. 1 plus 8, 9. But then it doesn't stop at 9. What if it's 99, you get 18, right? So and then if I add the digits again, I end up in 9. Does that make sense? So eventually you get to 9. Eventually get to 9. All right, good. How about 6? Let's look at 6. Multiple, so 6, 12, 18, 24, 30, blah, blah, blah. Okay. And if we add the digit, it's 3 as well. But then it's not enough just to be a multiple. Hang on, what's that? 9. So 6. Okay, so how do I divisible by 6? If it is, anyone want to try? Raise a hand. Emily? Excellent. So you have to check 2 conditions. Note 2 conditions. All right, so 6 you need to have divisible by 2 and 3. Okay, we're almost done. We've got 2 more to go through. The last 2 is a bit more complicated. Okay, let's do first 5 multiples of 4. So 4, 8, 12, 16, 20, etc. Not much pattern. If we add digits, sometimes 3, sometimes 7, all become random. Okay, but watch what happens if you do things after 100. 100 is divisible by 4, 104, 108, 112, 116. So it looks like, what do you notice? If you want to try, this one's a bit tricky. Harrison?
The numbers after
Yes, good. Yep, yep, good. So how do we organize it as a test, as a diagnostic? Go. Yes, so that means we only have to concentrate on the last two digits. A number is divisible by 4 if the last two digits. So it doesn't matter how big it is. I don't care it's 1 million something. You just look at the last two digits. If the last two digits divisible by 4, that's it. And finally, we've got divisible by 8. It's a similar story about 8. First by multiple, again, not much pattern. 24, etc. And then things repeat after 1000 because 1000 divisible by 8. So the same rule. So the last three digits. So 8's a bit more tricky. Okay, so we now have all three tests. Now, raise your hand, be conscious if you know which digit we haven't tested. We test 2, we tested 3, which one we haven't done? Okay, William? No, one's easy. One goes into anything, but there's one I missed. Brooklyn? 7. Thank you. I'm sure you had the same answer. Now, 7 is very tricky. And if the test is so tricky, you might as well just divide it. Does that make sense? So there's no simple test for 7. So therefore, we just do the long division. So we've got divisibility test for everything. So this is the conclusion we have. All numbers divided by 1, we don't need it. These are the tests. Last two digits must be that. 3, the sum of digits must be divided by 3. So have you look at the list and use that to do the question? Okay. Now we're going to do one question in the textbook. There's a question like this: 48,569,412. So what you need to do, all right, break. In the textbook, you need to show working. It's not enough just to say yes or no. We need to see reason. In the test, I need you to provide correct reason. Yes, Harrison? Okay, let's finish this. So I'm going to do a couple and then I'll get you to finish. So for example, divisible by 2. Yes, why? Last digit is even. It's enough to say even, or you can say last digit is 2. 3, you have to add up the digits. Look, are you going to do long division of that? Takes too long. Add the digits. Watch. And in the test, you got to show working. What's that? Now, I do 3 at a time. 12, 11, 13, 3, not enough. 23, 16. What's that? 39. Now 39, if you are not sure about 39 being multiple 3, I know that. Add them again, 12. And eventually it becomes 3. You keep adding the digits. So you should always end up with 3 or 6 or 9. Does that make sense? So we say yes, because the last digit, because the sum of the digit is a multiple of 3. Yes, because sum of digits is a, or that should is a a, or sum of digit is sum, sorry, my grammar is not perfect, is a multiple of 3. Okay, let's look at the next one. Divisible by 4. Divisible by 4 is, we have to check the last two digits. 12, oh my god, that's easy. Is a multiple of 3, is a multiple of 4, is a multiple of 4. So therefore, this is a multiple of 4. So that means I could make up any question. Say you're working in primary school, I'm going to give that person a very hard question to divide. You can just make up anything. Just say we start off with, say, let's say 16, right? I could make up any number and can do a bet. Would that be divisible by 4? And you're going to win the bet for sure, because you know that 16 will save you. Does that make sense? Okay. All right. I'm going to ask some people to answer the next one. Raise your hand. Again, I need a reason. Is this divisible by 5? Raise your hand if you know the answer. You have to give me the right reason. Okay. Cassidy, go. There's not any of them. There's only one digit too, right? It's not that there's 5 that works. It has to check the last digit. So the last digit. Okay. All right. So So the last, yeah, okay. So the last digit is not 0 or 5, so therefore no. Okay, good. Someone else to answer the next one. Who want to try the next one? Raise the hand. Okay, Julian, go.
Yes.
Why?
Because it is the last two digits are divisible by 2.
Not the last two digits.
The last digit is divisible by 2.
Yeah, but that's even. I'm 6.
Okay.
All right, that's okay. So what you need to do, remember, you have to check two things. Which two things you have to check, Harrison?
The number 2 divisibility test and the number 3 divisibility.
Yeah, what's the number 2 divisibility test?
Yes.
Yes, because it's even. And what else? Is it divisible by 3?
Yeah.
We have checked that already. Also divisible by 3. So therefore, divisible by 6. Okay, so you have to check two things with 6. 6 a bit tricky. Okay, how about 8? We have to check the, what do we have to check? I'm going to ask Sukman. Divisible by 8, how do I check? Just tell me the rule. Do you remember the rule?
It's the last 2 digits.
Last 3 digits for 8. Okay, last 3 digits. So, okay, actually, I just come up with the rule. Ah, yes, I got the rule now. Notice that I just come up with this. 8 is 2 cubed, last 3 digits. 4 is 2 squared, last 2 digits. And 2 is 2 to the power 1, last digit. That's how I remember now. If you look at the power, 2 to the power 1 is 2. Look at the last digit, 1 digit, 2 digits, 3 digits. Doesn't make, oh, if you don't get it, doesn't matter. Okay, last 3 digits. So we check it. How do I check it? Long division. Divide by 8. How many 8 in 4? Nothing. How many 8 in 40? That will be 5. Remainder 1, 12. How many 8 in 12? 1. Remainder, no. So it's no, because it's not divisible. There's a remainder of 4. Does that make sense? All right, lastly, 9. Remember, sum of digits we found out was 39, right? Is that divisible by 9? Well, if we add the digits again, you get 12. So no good. You should eventually end up in 9. So you didn't get up to 9, so no. So no. So divisible by 9 if the sum of digits must be a multiple of 9. And finally, by 10, last but not least, you want to try the last one? For someone who's been quiet, Ella. Ella, how well? Go. Yep, that's not n in 0. Does not end in 0, therefore not divisible by 10. Okay, we had a lot of fun together. That's good. Can we start the exercise today, 11A? Thank you. Well done.